Hi, welcome to this class. This class is extremely important since we will be talking about tissue and cell culture. Now, tissue and cell culture, when we talk about tissue and cell culture, it is important because when we our topic itself, our course itself says that we are developing a fabrication techniques for MEMS based sensors from clinical perspective. So, clinical problems are all the problems related to our health, and when we talk about our health, about human body finally when you go down, it is all about cells, right. So, if you have a device and if you want to load the cells, if you have a device and if you want to load organoids or spheroids, if you have a device to test the tissue properties, then how to culture those tissues and cells, right, and what kind of laboratory could handle this kind of tissue and cell culture, what kind of equipment should be there, and what kind of media that you will be using to grow the cells, and then what kind of technique is used to scrap the cells, how many cells have grown in particular petri dish or a T75 flask, and lot of other things similar to that we will be learning in this particular lecture, right. A little bit of biology, but interesting, right, engineer talking biology, so it will be interesting. Of course, biologists when they talk biology it will be even more interesting. So, let's go through this journey and see. So, tissue and cell culture techniques. So, when you talk about understanding tissue and cell culture techniques, you are not only talking biology, but you are also talking engineering, you are talking about medicine, right, and then you are talking about biology, and when you talk about all these things, then they are all interrelated. It is like no one can live without the another one, right. See, bioreactor, monitoring control, therapeutics, diagnostics, tissue engineering, cell stability selection, cell engineering, all these things are interrelated. Okay. So, we will be looking at this from engineering point of view and medicine point of view, keeping biology at the center point of the talk. So, because our devices that we are designing are engineering devices, the problems that we are addressing are medical problems, and the techniques that we have to use are biology techniques. Thus, all these three are interlinked, right, a triangle that interlinks. Is not finished? Okay, let us finish the triangle. Cool. So, what is cell culture? So, what is cell culture? First thing, defined as the process of cultivating cells and tissues outside the body of an organism, right. So, let me tell you a few terms. First term is in vivo, vivo, in vivo, in vivo, it is within body. Next term ex vivo, outside the body. Next term in vitro, right, or in laboratory environment, artificial environment, in vitro. So, let us see. Defined, what is cell culture? Defined as a process of cultivating cells and tissues outside the body of an organism, that is ex vivo, in an artificial environment like petri dish, which is in vitro, right, which replicates the in vivo conditions such as temperature, nutrition, and protection from invading microorganisms. Cell and tissue culture are terms that are used interchangeably and basically denotes growing cells or cluster of cells in vitro, right. You take a cell, load in a petri dish, load a particular media, and it will start growing, right. So, it can be it has a interchangeable terms that we use, cell and tissue culture. It was first time successfully undertaken by Ross Harrison in 1907, just trivia. So, the cells may be removed from the tissue directly like primary culture, and disaggregated by enzymatic or mechanical methods before cultivating it, right, and then they may be derived from a cell line that has already been established. There are two ways of taking out the cells. So, let us see both ways in the next slide. You see here, first one, organ. So, cells isolation by enzymatic or by mechanical action, it is cultured and confluent culture is ready. Once the confluence culture is ready, the secondary culture or primary line is formed, right, secondary line subculture, right, we go on doing it, cell division continues up to finite divisions, right, the primary culture, it is a primary culture, you got it. So, what we do is we take the tissue, we take out the cells from the tissue either by enzymatic or mechanical actions. Once the tissues are when the cells is out, we culture those cells, and once it reaches its confluent state, we do secondary culture and perform a secondary cell line to finally we keep on culturing it until cell division until some finite divisions. Second way of doing it, organ having a tumor, cell isolated from tumor and cultured, right, transform cells, subculture, cell division continues up to indefinite divisions, right. This is about primary culture. So, what is primary culture? When cell are surgically removed from an organism placed in a suitable culture environment, attach, divide and grow, they are called primary cell culture. These terminologies we need to understand, so that when we talk about tissue culture, it is easily understandable when this kind of terminologies are used, like cell culture, primary cell culture, cell line, adherent cells, confluence, passaging, right. So, we need to understand. So, when we talk about primary cell culture, as we have seen, cells surgically removed from an organisms and it is placed in a cultural environment, and that will attach, divide and grow. Cell line, what is cell line? Cell line, when the primary cell culture is subcultured and they are demonstrated an ability to propagate indefinitely, is called a cell line. Then there are adherent cells. Adherent cells are when cell grows as a monolayer attaching themselves to the substrate like glass or plastic, it is called encourage dependence. Encourage dependence, that is like anchor, right, anchoring. So, because the cell will stick to the glass or plastic in a monolayer. Next term comes as confluence. What is confluence? Terms used as an estimate of the number of adherent cells in a cultural dish or flask and refers to the proportion of the surface covered by cells, is called confluence. Passaging, the process of splitting or subculturing the cells is called passaging, right. Now, once we know this some terms, right, like passaging, cell lines, confluence, cell culture, what kind of laboratory or a tissue culture lab setup looks like? So, a basic tissue culture lab should look like the one that I am showing here. However, there are several kind of different setup also. So, just to see, you see here there is a cold room, then there are air storage freezers, stereo glasswares are kept here, liquid, sterile plastic cylinders are kept, right. Then this is the area where people work, there are incubators on all the sides, right, and there are microscope room, there is a hot room, there is a quarantine room, then this is a corridor, right. Again water purification, ovens and autoclaves, dryer, glassware, washing machine, sinks, right. This is typically how a setup looks like. Now, we have taken an example from Caltech but similar kind of short facility or smaller facility we are also developing right in my department, which is electronic systems engineering in IISc. Right, and it will not only have the cell culture lab, but it will also have a micro engineering lab where you can fabricate the device, and within the same environment you can test the device in this kind of facility. Now, we always talked about clean room, right. So, what is clean room and why it is important? So, generally a tissue culture room needs to be preferably housed in a clean room environment, and around 10,000 class 10,000 would be an ideal environment for such kind of activity. A typical clean room looks as shown in figure here. You can see here this is a clean room, right, and you can see that you have to wear gown, right, to avoid any contamination, right. Is a typical clean room for fabricating device. Okay. But we can work around if we have class 10,000 clean room environment. Now, clean rooms are classified based on the amount of particulate matter obtained within the target space. So, within a space how much particulate matter is obtained. Also there are ISO classification as well as FED classifications. You can see here in the table where you talk about ISO 1, then it is really clean, about 10 greater than 0.1 micrometer particles, 2.37 for 0.2, 1.02 for 0.3, and these maximum particles are per meter cube, per cubic meter, per meter cube. When you talk about class 1, right. So, that will be ISO 3, and it is a clean room which has about 1000 particles which is greater than 0.1 micron, about 237 greater than 0.2, and so on till 0.5 till 5 microns. But when we talk about a Fablab, that is a Intel class room, right, Intel Fab 32, that is rated as class 10 clean room, and if you see class 10 clean room is here, right. So, it would have this particular specification. Then comes class 100, then comes class 1000, then comes class 10,000, then comes class 100,000, and then our laboratory which is cleaner, and that is our room air, right. So, for biology, for pharmacy, generally class 10,000 is used for experiments, right. We have, and we will show you, we will give a tour to my laboratory here in my department, which is a class 10,000 clean room facility. And like I said, we are in process of developing another laboratory with a cell culture as well as the microfabrication facility, which will be class 1000 clean room. But for now, for this particular lecture and course, we will be understanding class 10,000, and we will be looking at class 10,000 in reality, and what kind of equipment are there within the class 10,000 clean room environment, right. So, like if you see the screen, what you see here is Intel Fab 32 is rated as class 10 clean room, meaning there are no more than 10 particles measuring 0.5 micron or larger per 1 cubic foot of air, right. You can see class 10, no more than 10 particles. Now, generally when you see a fab lab, you will find that in a conventional clean room facility, which is 100, 1000, 10,000, right, you will find several equipment such as LPCVD. We have just talked about CVD, right. chemical vapor deposition, low pressure chemical vapor deposition. There is a PECVD which you can see here, right, is from Oxford, I think, yes, it is from Oxford. Then we have Tystar CVD for your wet oxidation, dry oxidation. Then you have your CMP for polishing the wafer. Then you have dicing saw for dicing the chips. Then you have bonder for bonding silicon with silicon. So, you need that kind of application when we are making a microfluidic chip. Then you have a thermal evaporator, then you have a parylene depositor, this is a plastic deposition, polymer deposition, you have a sputtering system, you may have a e-beam evaporator, you may have a Denton e-beam thermal evaporator, that is a thermal evaporation, you have a photoresist spin station, you have a polymer spin station like SU8, you have a EVG 620 mask aligner, you can also have a MJB4 mask aligner, right, like you can see here it is a MJB3, you can have MJB3, 4, whatever mask aligner, in general mask aligner would you will see. Then you will see a plasma system for bonding glass with PDMS, then you may have wet etching, you have RIE, you may have fluorine, chlorine, and you may have DRI. So, these are the like a few of the equipment that you will generally find in a clean room, conventional clean room, which is 100,000, 10,000, even class 10. But what we also see in a clean room where the biology experiments have to be performed. In such a kind of clean room, you may have where you can also design, you can design the device, you can fabricate the device, and you can perform experiments, right. Such kind of facilities are available in few of the top class universities across the world, and we are trying to replicate a small facility over here as well. So, that kind of clean room where a person can work at the interface of biology, medicine, and engineering, you will see a thermal evaporator, you can see a pathology workstation, there will be a 3D cell culture, a biosafety hood, right. It will be a imaging microscope, there can be spin coater, there can be peristaltic pump, there can be upright microscope. You see peristaltic pump, spin coater, upright microscope, or metallurgical microscope, biosafety hood you can see here, right. You can see a fume hood here, you can see a micro manipulator here, you can see a incubator or a oven, right, a DI plant, oxygen plasma system. So, and it is not limited to only this many equipment, there can be few more, like there can be wet etching, right, it is a acid wet etching and can be solvent, right. Then you have a mask aligner, you have a inverted microscope, fluorescence microscope, you have HEPA filters, right, you have a autoclave, you have the system for tissue, right, tissue microarray and microgrid, and it is also called microtome by the way, and of course, you have the vacuum oven that you can see here. So, lot of things you will see in reality in the laboratory. So, let me tell you what you will be looking at when you actually go to the Fablab. We will show it to you as a part of this course, right. We will show you the microscope, all three microscope will show you metallurgical microscope, inverted microscope, and stereo microscope. We will show you this biosafety hood, right. We will show you micro manipulator, we will show you oven, we will show you a incubator, we will show you peristaltic pump, right. Then we will also show you HEPA filters, we will show you a oven, and we will show you autoclave. Alright. So, it will be like half an hour or 1 hour on each of the system. So, you understand how it can be operated, how it can be used, not just to show you what facilities should contain, what equipment are there, no, to show you how to operate that equipment, right. If you and how to enter a clean room, what kind of precaution you should take, what kind of garment you should wear, right. You should wear a full sleeve, you should have a toe cover shoe, right. It should cover your toe, you should have wear a coat, lab coat, gloves, right, a beer covered, a hair cap, right, goggles to protect your eye, So how can you how to enter a laboratory? Once you enter the laboratory, what kind of equipment are there? Once you see the equipment, how to use this equipment, that is the idea, and that will be the part of this particular course as well. So when we, if you see the slide, when we talk about this equipment, let us see some similar facilities around the world. So if you see the screen, what you see is Biomolecular Nanotechnology Center, which is at Berkeley. You can see here, right. This is a unique fabrication and experimental facility specializing in biomems, biomedical, microelectromechanical system and microfluidic devices. These exciting technologies are poised to revolutionize medical diagnostics, analytical chemistry, proteomics, genomics and cell biology. You can see biology experiments that should be done in a clean room, class 10,000, right. Same way, if you see nanobio lab at Weizmann Institute of Science, Israel, they have the similar kind of facility. We have similar facility at Fuji Electric, and we also have a separate brick nanotechnology center at Purdue University for, especially this is a whole center dedicated for biology pharmaceutical clean room to facilitate nanotechnology research in collaboration with Binley Bioscience Center. So point is, do we require such a big thing? I am not saying we should have this, right. What I am saying is, if class 10,000 environment, a clean room environment is provided, then we can do research in multiple areas of biology as well as medicine and pharmacy, and work on biomedical devices and so on and so forth. So now when we talk about clean room, the most important equipment or a tool is HEPA filter, right. So what exactly HEPA filter is? So the critical particulate concentration is controlled and maintained in a clean room environment using a HEPA filter, and HEPA stands for high efficiency particulate air. So generally when you see it works like this. So there is a exhaust air that goes through here, and there is a coarse filter, there is a rotary air heat exchanger, there is a electrostatic cleaner, there is a HEPA filter, and the fresh air goes like this, the exhaust air goes back, right, and this is how it works. There is a positive pressure module and there are tower modules that can apply a positive pressure. A representative air cleaning setup is shown here, right. It usually consists of positive pressure module that cleans the incoming air, and the role of positive pressure module is to clean the incoming air. An array of filters that then pushes the air into the room and to maintain it at a higher pressure, so that particles do not easily enter, right. So that is the advantage of high pressure, so that the particles from outside would not enter the room. Along with positive pressure module, there will be a tower module for circulating of internal air. These are also shown, right. You can see here on in the figure. This HEPA filter system forms a core mechanism through which the clean room environment is maintained. HEPA filters are used to keep the clean room environment stable, right. So for this particular module, let us stop here, and we have to see another part of this particular lecture in the next module, where we will be looking at equipments, some chemicals related to it, then how they are used, right, how the tissue culture is done, how the cell culture is done, we will take in the next module as a part of the same class. Till then you just go through it. This is more like an informative lecture, so that you understand what kind of facilities are there and how you can culture the cells as well as tissue, right. Till then you take care. I will see you in the next class.